Okay, so our last kind of example is going to be to find a formula for a given function. All right, so I've given you here two graphs. Let's look at the one on the left. All right, so this one kind of looks like the absolute value of x graph. Okay, usually absolute value of x, let's just kind of draw it here for reference, goes on a 45-degree angle in a V shape. Okay, so we got to figure out what's happened to this graph. Okay, so it's obviously been flipped upside down. Okay, so let's take some notes here. I've got the absolute value of x, and I've had a vertical reflection, or a vertical flip. Okay, now when I draw that vertical flip, the regular absolute value of x graph would still be going along those 45-degree angles. Okay, so let's draw that in a different color. If I flip that green graph over, that would look like this. Okay, so my graph is lower, but it's not lower because I've just picked up that V and shifted it down. It's gotten a little bit skinnier looking, meaning that it got stretched out vertically. So let's figure out by how much did it get stretched vertically. All right, so just pick a blue point on this graph. It used to have a y coordinate of -1. Now it's got a y coordinate of -2. Remember that these stretches are done by multiplication. So it kind of looks like maybe I've multiplied by 2, but I want to double check. Okay, so just pick something like here. I've got this point on the original blue flipped graph at 2, -2. And sure enough, the y coordinate is 2 times as big as that. 2 times -2 would give you -4. Okay, so this has had a vertical stretch times 2. Okay, so we need to incorporate a vertical flip and a vertical stretch on an absolute value graph. Okay, so the vertical stretch, I would have to multiply the function by 2 on the outside. All of our stretches and shrinks were done vertically. And then I would need to add in that reflection. A vertical thing always happens outside the function. So I'm going to put that negative multiplication, a -1 times that 2. And that's going to give me that vertical reflection and stretch. Okay, so let's try the next one. Okay, so hopefully we recognize this one as being a square root graph. All right, normal square root graph. Again, I'm going to draw myself a little reference graph. Normally starts at the origin. Square root of 1 is 1. Square root of 4 is 2. Okay, so already I'm kind of thinking this one has been stretched as well because it's kind of a little bit taller, but still stuck to the x-axis. The first thing I notice is that this has been moved 2 tick marks to the left. Okay, so we've gone left 2. All right, but even if I recopy that shape, moved left 2, it would be here. Okay, so we have to figure out, once we've gone left 2 with the square root graph, what else has happened here? And it looks like, again, it's been stretched. So let's track some of the points that we know. Okay, so I've got this point on the regular root x that's been shifted, and that's been stretched out to that point. And again, the only other reference point I've got here has been stretched out to that point. Okay. And again, stretching happens by multiplying. So multiplying a y coordinate of 1 to 3, it's multiplying by 3. And so times 3. Same thing has happened here, right? A y coordinate of 2 turning into a y coordinate of 6. I've multiplied by 3. Okay, so this is another vertical stretch. This time times 3. All right, so let's see if we can put that together. So we're going to have a function. I need to move it left 2. So I need to add 2 on the inside. Okay, so I'm going to take my square root symbol and I'm going to say x plus 2 on the inside. All right, if I put plus 2 on the outside, that would move the graph up. So we want plus 2 on the inside. And then our vertical stretch times 3, that's going to be multiplying the whole function by a 3. All right. And so on homework, it's very easy to hop over to Desmos and graph these and make sure that you get everything in the right place. All right, so that's it for transformations of function, and we'll be starting something new next time I see you.